Imagine that you are at the edge of a black hole, just about to enter the event horizon, and boom, you are now inside of a black hole. You are anxious and scared, you don't know what to do, you are just thinking, is this the end? Or is there any way to escape a black hole? Let's find out in this video. Your first thoughts may be of accelerating out of the black hole, but you can't because the escape velocity, which is the velocity required to escape it, is more than the speed of light, and we can't travel faster than the speed of light. So you are left with no choice but to continue your journey inside a black hole and find a way to escape it. But before escaping, you first need to know about the black hole. Well, they are derived from Einstein's general relativity, and in this video we are gonna focus on a rotating black hole, which was discovered mathematically in 1963 by Roy Kerr. Outside of a rotating black hole is the event horizon, from which, if entered, nothing can escape. Because as I mentioned, escape velocity reaches the speed of light. However, just before the event horizon is a region named the ergosphere. Now to understand ergosphere, we have to understand a phenomenon known as frame dragging. It is the twisting of space-time because of the rotation of a black hole. When a black hole rotates, it twists the space-time to such an extent that it creates a sort of whirlpool that drags everything in it to the black hole. Now in the ergosphere, frame dragging is maximum and anything in it will have to rotate in the direction of the black hole and ultimately fall into the black hole. But there is a way to escape it. And yeah, I know that you are inside of a black hole, not in the ergosphere, but just bear with me for a moment. Because if we place an object precisely into the ergosphere, the thing is that half of that object will fall into the black hole. However, the other half will have to leave the ergosphere with a greater velocity than it entered. So the ergosphere can also be used to extract energy if we have the resources to. But now let's go inside of a black hole, because the physics is just starting to get spicy. Because a rotating black hole has another event horizon. I mean, it's different from the one before. And this one is known as the inner horizon or the Cauchy horizon. And let me tell you that you are in a great danger here. But don't worry, because I have a plan. Anyway, here space-time is the most volatile because anything that falls into it gains energy and its wavelength decreases. This is known as blue shifting, and the objects in the inner horizon get infinitely blue shifted and they become unstable. It basically means that you are screwed unless you approach the inner horizon along the equatorial plane. Now what I mean by this is that if you reach the inner horizon from the middle and not the poles, your chances of survival can increase. Because the rotating black hole generates a centrifugal force which exerts more tidal forces and gravitational effects at the pole, which means that objects at the poles like photons would be intensely blue shifted. And if we go along the equatorial plane, we can avoid colliding with these blue shifted photons, at least to some extent. Moreover, frame dragging at the equator is also more predictable, so we can use it to our advantage to slow down our speed. So even if we collide with such hostile particles, the effect can be cut down drastically. Now to execute this perfectly, we have to go back to the ergosphere, because if we maneuver over the ergosphere precisely with meticulous calculations, we will go into the black hole such that the geodesics, which are the natural paths followed by an object inside of a black hole, would automatically be of the equator. That is how we can safely go through the event horizon. Additionally, we would also need some good protection around our spaceship, but this can work too. That was a close call. But hey, you survived and you are actually very close to freedom because you are near the singularity of the black hole. That may sound scary, but actually the singularity of a rotating black hole is different from a non-rotating one because it is not a point which is the end of everything. Instead, because of the rotation of the black hole, it has taken the shape of a ring, and hypothetically it is considered that if we go inside the ring in such a way that we don't hit its boundaries and enter through the hole of the ring, we might survive because this ring singularity may act as the gateway of your freedom. But before I tell you how, don't forget to like the video and subscribe to the channel. Anyway, hypothetically this singularity is considered to act as a wormhole which can connect different universes. This theory was further aggravated by Roger Penrose and his famous Penrose diagrams, which give the outline of how a singularity can actually be the gateway to connect different universes. But I know what you're thinking. I don't want to go to another universe, I just want to go home. Well, for that we have to further stretch the limits of theoretical physics. And what I'm about to say may sound a bit vague, but trust me, it is possible. Hypothetically, of course. What we can do is, we can steer a wormhole. It means that instead of the wormhole connecting to another universe, we can sort of turn it back. so that it connects back to the other side of our universe. Now to do that you need a hypothetical material known as exotic matter, which some might say doesn't exist. But it is our only option, because to manipulate something like a wormhole you need an even stubborn material. Another way can be by just exiting from the wormhole into another universe, then going inside the black hole of that universe and repeating this process again and again until we hit our luck. Well, congratulations, you have just escaped a black hole. But I have a little bit of bad news for you. Because all of these processes that we just did are highly hypothetical and somewhat incomprehensible to the practical physics field. But hey, who cares? You just survived. So go party somewhere. But before you do that, make sure to like the video, subscribe to the channel, and watch the video on why Elon Musk's Mars mission will fail.